Okay, before we move on to the next example, I want to emphasize a couple things. You'll notice here we have two variables on the right. We have r squared and we have h. When dealing with rate of change, you want to try to get it down to one variable. So in this case, we knew that the diameter was 3 times the height. Well, the radius, of course, is half the diameter, so it's 1.5. We got everything in terms of the height, which is also what we're looking for anyway. At what rate is the height of the pile changing when the pile is 15 feet high? So we got that. All right, now for the next one, it says air is being pumped into a spherical balloon at a rate of 4.5 cubic inches per minute. Find the rate of change of the radius when the radius is 2. Okay, here's what we know. You know that the volume of a sphere is 4/3 pi r cubed. Okay, you're supposed to know that. You learn that in geometry, but you can look it up. You can Google it. It's not that big of a deal. But with that being said, we need to see what we do know. We don't know the volume, but we do know that the rate of change, so the rate at which the volume is changing is 4 dV over dt equals 4.5 meters cubed, or excuse me, inches cubed per minute. And we also know that the rate is going to be 2 inches. So let's derive this. That's going to be dV. I am not writing well today. I apologize, folks. I am not writing well. dV over dt equals, and we end up with 4/3 pi times 3 times r squared, which when that simplifies, dV over dt equals 4 pi r squared. Now, and that's also dr over dt. I forgot to mention that. Okay, I want you to look at this real quick. 4 pi r squared. You'll notice that that is the surface area of a sphere. I showed that to my geometry kids one day a couple years back, and I showed them how to derive it. They had no clue. I said, you'll learn it in calculus one day, but I thought I'd have a little fun with them. But anyway, with that being said, here's what we do know. We are looking for the rate of change of the radius. So this is what here is what we're looking for. We're looking for that. But we have everything else. We have 4.5 inches cubed per minute equals 4 times pi, and we know that the radius is 2, and we don't know dr over dt. So I'll let you finish that out from there. I will let you finish that out from there. You can take it from there. Okay, I'm going to go over the next one with you, but I will post Saul's version of the last one on Canvas so you can look at it on your own. But I want to see what you can. I want you to see what you can do on your own after this next one. Okay, example number 4, or the fourth example. Okay, a square baseball diamond has sides that are 90 feet long. A player 26 feet from third base is running at a speed of 30 feet per second. At what rate is the player's distance from home plate changing? All right, I went ahead and wrote a couple things down from the information. We know it's going to be Pythagorean theorem, so a squared plus b squared equals c squared. And I went ahead and labeled this diagram. I labeled this part A. That's the distance from the runner up to third base. B, which is 90 feet. If you know anything about Major League Baseball, the bases are 90 feet away. So I don't know much about baseball, but I do know that. And then C, that's what's changing, but that's what we're going to be looking for as well. So we'll be computing that, and when we do compute that with the information, we get approximately 93.68 feet at the moment when A is 26 feet, and B, which is the standard 90 feet, the distance between the bases. All right, so now this is going to involve plugging in what we know and doing some deriving. Okay, now we're looking for the rate at which the player's distance from home is changing. So that's going to be, we're looking for dA over, or excuse me, we're looking for dc over dt. All right, so let's derive this real quick. That's going to be 2a dA over dt plus, well, anyway, b is not changing because it ends up being all right. Now remember, B we already said was 90 feet, so when we square that to 8,100. That's how 8,100 feet squared, but when we would derive it, you get 0 equals 2c dc over dt. All right, so a player 26 feet base from third base is running at a speed of 30 feet per second. So we know the following. We know that 2 times 26, which is A, times dA over dt, which is 30 feet per second, equals 2 times C, which we said was 93.68, and we're looking for dc over dt, which you can figure out what that is from the algebra. All right, so you can do all that. I will post this. I will also post the rest of these notes, Saul's version, but I want you to try and do the last one on your own. It's a little bit of a challenge, but I think you can handle it. I will put Saul's version on you and then we can start preparing for your chapter 2 test, which is coming up very soon. All right. Have a good day, folks.